All right, hey, welcome back, class. So I thought I'd start out with crazy train because this is about the craziest train you could be on right now, which is geometry class. So in this video, what I'm going to do is we're going to start exploring a little bit more about coordinate geometry. We're going to be doing a flipped classroom scenario for this entire unit. So what that means is that you're going to be watching these videos, me, at home or for homework. And then in class, we're going to actually dive in some more and actually start getting some hands-on stuff. So this is going to save us time. It's going to actually give us a better chance at understanding and grappling some of these concepts ourselves. And let's go ahead and get started. So a lot of this unit is going to be pretty self-explanatory because guess what? You already know how to do it. Okay, Unit 3 is all about using our idea of slope, lines, and start using the coordinate Cartesian plane and develop these geometric relationships on a grid. So that's what we're going to do here, but first we got to review a few things, right? It's because everybody remembers everything there is to know about slope. I can just move on, right? No, unfortunately not. So for this unit, what we're going to do is we're going to take a look at some, well, first of all, we're going to take a look at the objectives which we're going to cover. So if we take a look, we have calculating slope. Hold on here, let me get my fancy pens here. Oh, we got some highlighter, pink there. Calculate slope, we're going to graph lines using various forms. That means our standard form, our point slope form, slope intercept form, all that good stuff. We're going to transform some of our forms. So a lot of forms going on here. Write equations using point and slope. Solve equations by graphing, blah, 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 blah. You can sort of see where we go from there. But really, we start getting into the geometry right around 7, 8, and 9. Now, I know that looks like, okay, 1 through 6 is all going to be review, Mr. Korb. Why do I need to do this? Because I already know this. Because unfortunately, because Algebra 1B may have been a long time ago for you, or Algebra 1A, we do have to review it. So that's where we're at. So let's take a look at 3-1. We're just going to discuss what slope is, and then we're going to continue on in our mini-series here. So 3-1 is slope. What is slope? What is it? You know it. It's the steepness of a line, right? Okay, so we have the steepness of a line. So if I have a slope like this, okay, this is a negative slope, right? It goes down and to the left. Okay, what about this? This is a horizontal line. It has no slope. And you can see how steeper it gets as long as I start increasing the slope a little bit more until I fall off the chair, right? Nope, just kidding. Okay, so we have slope is the steepness of a line, and the letter M is always used to represent slope just because. Finding slope in a coordinate plane. So this is on a graph. We're going to use rise over run. Okay, finding slope given 2 points on a line. So if I have 2 points on a line, I have this little formula that I know of, which is delta y over delta x. Whoa, Mr. Korb, what are you talking about with this delta thing? Well, delta is Greek. It's just going to mean change in this case, so change in y over change in x. So we do have a formula instead, which is y2 minus y1 over x2 minus x1. So this is one that you should be familiar with. We have 2 points, right, on the coordinate plane. We have an x1, a y1, and an x2, comma, y2. If we're trying to find the slope between those two, we got to find the difference in the y's and then the difference in the x's and divide. So we're finding that change, that relationship. It's always a fraction. Okay, what do we know about the slope of 0? The slope of 0 is going to look like this, right? It's a horizontal line. So we know that m is equal to 0. It's a horizontal line. Undefined slope, that's its counterpart here. Undefined is just up and down. It doesn't cross the y-axis at all. It doesn't have a definitive slope because if we look at this slope and we start at this point and this point, it has run, but it doesn't have any rise. So we can have 0 divided by, say, 4, but we can't have 4 divided by 0. We can't divide by this 0. This is not going to work. If that happens, then if this is the world, right? Okay? If we divide by 0, boom. world explodes, right? No. But you know that we can't divide by 0, so this is going to be an undefined slope, because we don't really have one in this case. Okay, so moving on, let's take a look here. Actually, let's back up. I want to show you a short little thing that you can do to sort of understand this a little bit better. So if I'm going to draw you a picture. Oh wow, arts and crafts time with Mr. Korb. Aren't you lucky? Okay, I'm going to draw Slope Man. Da-na-na. Right? Slope Man. So we have this guy here. We're going to give him some eyebrows. He's sad because he didn't get to go to math class today. Okay, but this slope right here is going to be positive. This slope is negative. So this side he's winking at you. Negative sign. Watch out. Okay, also, let's give him a nose here. And let's give him a mouth. Okay, so we have a positive slope. So you can remember this is a positive slope up and to the right. We have a negative slope down and to the right. And then we have this undefined slope, right? If I would make this into a line, undefined, so this is his nose. And his mouth is a slope of 0, right? Because it doesn't change up and down. All right, cool. So that's Slope Man. Say hi. All right, continuing on. Let's actually put this into practice real quick. So if I find the slope of each line, we can look at this graph over here. And we're going to count rise over run. So we're going to go up 1, 2, 3 over 2. So this is a slope of 3 over 2. Find the slope of a line containing the 2 points. So I have this point here and this point here. We're going to use our y2 minus y1 over x2 minus x1. Okay, let's plug these things in. Side question, does it matter which one is 1 and which one's 2? No, it does not. It is a-okay to use either one. You'll still get the same solution as long as you go one direction, not the band. Okay, but if we're going one direction, that means from this point here, let's label this as 2, and this one is 1, just for our sake right now. 14 minus 4 over 2 minus negative 2. Don't forget this negative sign there. We have 14 minus 4 is 10. 2 minus negative 2 is 4. Can I leave it as that? No, I can't. Good try. 5 over 2 is better. M equals 5 over 2. Bada bing, bada boom. You're done. Sweet. So go ahead and pause the video right now if you want to try 3 and 4. I'm going to show you those answers here momentarily, and that's going to wrap up our first section of Unit 3. All right. Some motivational music until you get those problems done. Okay, so here are the answers that we came across. So on the left-hand side, we have 3 is negative 1/3, so we're going down and to the right. Anytime you have a line that's going down, it is a negative slope. So make sure your final slope is negative. And then lastly, if I can talk, we have 1/3 as our slope because I found using our formula of y2 minus y1 over x2 minus x1. So this has been Mr. Korb. I will see you next time, and we're going to dive a little bit deeper into 3-1 and move directly into 3-2 for this unit. Adios, and I'll let Ozzy take it out.